According to the data presented in this slide, the job titles of shuttle car operator and continuous miner operator have higher accident rates in deep cut mines by 20% and 63% respectively. These jobs are prime candidates for further investigation through task analysis so that the reasons for these increased rates can be determined and safety measures developed.
A questionnaire was used to determine what aspects of deep cut mining are considered the most critical to the mining industry. So far, over 75 mine workers, including mine operators and supervisors, have been questioned at various mines with deep cut approvals throughout Pennsylvania, Kentucky, Maryland, and Ohio. The questionnaire addresses various aspects of the worker's experience, mine conditions, and the mine worker's view of safety of deep cuts. Our goal is to cover as many areas as possible to identify any problems particular to deep cut mining. In general, the results of the interviews were positive. 74% of the workers in large mines, those mines with greater than 100 employees, and 95% of the workers in small mines, those mines with less than 100 employees, said deep cut mining improved or maintained their productivity levels. The miners believe that deep cut mining is safer because they move the equipment less, thus decreasing the probability of moving accidents. They commented that they were more mobile and therefore able to get out of the way of the miner quickly and more safely than when on the deck of the miner. They also felt they were exposed to less noise and dust. Several concerns with deep cuts were raised. 67% of the operators interviewed said there were visibility problems, and 29% said that it was at least sometimes difficult to stay on sight line in deep cuts. Several of these continuous miner operators stated that a 40-foot cut is the maximum safe cut because visibility problems begin to occur after that point. Also, the operator's position when operating the miner has become an important safety concern in deep cuts, as voiced by many of the interviewees. The bolter's workload has been described as the heaviest of all job positions. The bolter operators are concerned that the miner operator will have to wait on them to finish bolting the section. 1/3 of the roof bolter operators in the study of 6 mines with deep cut approval said that they found themselves hurrying to stay ahead of the continuous miner every day, and another 24% said that this happens to them a few times a week. This workload may encourage the bolter to take shortcuts, either to keep up with the miner or to take a break. The type of shortcuts mentioned were spacing bolts further apart than the roof plan allows, or neglecting to do methane checks or drill test holes, and to check the torques on the bolts. Another important concern is the length of time between bolting. Some believe that the longer the top sits unbolted, the greater the probability of the roof sagging and possibly falling. 57% of the continuous miner operators interviewed were concerned that the roof falls in deep cuts were both deeper and have larger surface area than roof falls in standard cuts. 37% of the roof bolters interviewed thought that ground falls may be larger in deep cuts. It has been found that deep cut roof falls average 3 times larger in area and 1.5 times greater in thickness than non-deep cut roof falls. The Bureau has taken a systematic look at safety issues in deep cut mining through the use of the questionnaire, the statistical analysis, and past operator positioning analysis. One such experiment on operator analysis was completed at the Bureau in 1991. It studied operator positioning at several mines which were taking deep cut approvals. The study recorded the positioning of the miner operator backing through cross cuts, burst cuts, second cuts, and moving at the face. Each observation, occurring approximately 1 per minute, included the operator's position and his direction of view in relationship to the miner, the ventilation curtain, and the last row of bolts. The location of other workers and their equipment was noted along with the activity being performed. These observations were made in comparison to what the standard operating procedures depicted as the safe location for the operator in that mining activity. For example, during the first cut, the operator should be positioned in this safety zone. However, this is where the operator was observed. So 22% of the time, the operators were observed in an unsafe position according to the standard operating procedures. This comparison shows the difference between the standard operating procedure and what the operator really does. The difference can be attributed either to that the standard operating procedure is impractical or the operator is being unsafe. When interviewed, the operators said they had to position themselves there for visibility reasons. This may mean that we should take a closer look at developing practical, reasonable, and more importantly, usable standard operating procedures. The results of these interviews, past studies, and statistical analysis are being used to determine what areas need further examination. The Bureau plans to perform task analysis to break down the problem and develop possible solutions. The areas of interest immediately involve miner operator positioning while cutting coal and also when tramming from place to place. We're interested in what they need to see, where they need to be to see it, and the training of these tasks. We want to see what hazards may exist due to their positioning, such as pinch points, inability to see other workers, and the proximity to unsupported top. Roof bolting is also an issue. Recent fatalities have caused us to look more closely to the equipment design, the work procedures, and the workload. Is it as safe to bolt a deep cut as it is a standard 20-foot cut? Is the workload more taxing? How can the process be made more safe? We are working closely with other groups at the Pittsburgh Research Center to get a global look at the deep cut process. Other areas where some have expressed concern are ventilation plans, methane liberation and methane checks, dust exposure, and the general area of remote control. We are interested in any concerns you may have on this issue. Our plan for the next 1 to 2 years is to study several mines before deep cut approval is granted, and then go back to the study after they have acquired their deep cut approval. In this way, we can help to diminish the differences between mines when performing the studies. We are currently interested in the continuous miner and the roof bolter positions. Recent continuous miner operator fatalities have directed us to pay particular attention to crosscuts, breakthroughs, and tramming the miner from place to place. Roof bolter fatalities are driving us to research the mental and physical stressors associated with roof bolting as a result of the equipment and procedures followed. We expect to work closely with other projects such as the retreat mining, prevention of ground fall accidents, and small mines and independent contractors, since there is substantial overlap into these other projects. The outcome of this research will help us to identify and address safety concerns associated with deep cut mining objectively. This can lead to improved equipment design and job redesign recommendations. One outcome the Bureau plans to develop from this research is a method for mine management to use when implementing new mining technology, whether it is equipment or methods. This will provide them with a tool for evaluating the human factors aspects of technological changes and to better plan and design for these changes. We can help them determine their training needs and ultimately reduce accidents and costs. If you are interested in obtaining more information or would like a copy of the publication, the name of the paper is An Ergonomic and Statistical Assessment of Safety in Deep Cut Mining and is published as a special publication, SP 18-94, Improving Safety at Small Underground Mines. The publication is available through NTIS, 5285 Port Royal Road, Springfield, Virginia, 22161, or call 1-800-553-NTIS to obtain a copy of the publication.